So, Keith, I'd like to welcome everybody to to this Christmas special edition of TMS Tuesday. It's who would have believed at the start of this year that we would be doing this? I didn't even know the word Zoom existed, and now it's become a verb in the common in today's speech. So here we are for the last broadcast. We've done 16 TMS Tuesday webinars, and we've done a AGL training course. So it's been quite a year for us all. I'd like to first of all introduce Keith, our Director and Principal Trainer, TMS Training Solutions. Keith has a lifetime's experience in airports and airport engineering, a world-renowned expert in the field of changing light bulbs, including the development and delivery of numerous training courses. Keith is a founding member of the Airfield Lighting Association and guest lecturer at the Singapore Aviation Authority for the Singapore Aviation Authority and ICAO Regional Centre of Excellence. I'd also like to welcome Tony Smith again, fellow of the Royal Society and applied physicist, government scientist from 1955 to 1998, and he'll tell us some more about that later, with a specific focus on research and development of visual aids for pilots. And he's done an awful lot of drafting of standards and documentation. So, and has been such a support to us in TMS for a number of years, and an author of over 100 technical papers. So welcome to you both. If we can just kick on to the onto the next slide, Keith. Today we're going to be talking about a number of topics. First of all, we're going to be talking about the aviation. Keith is going to be giving us an aviation recovery update. We're talking a bit about the regulatory guidance that's been issued to support airports as we recover from the virtual stopping of commercial aviation activity in March, April of this year. And Tony will be giving us reflections of a lifetime developing visual aids and the associated standards, and culminating in his current focus, which is PAPI Siting Harmonisation and the work he's doing with ICAO on that area. And then Keith will be talking to us a very important aspect as we recover from COVID, about training for the next generation of aviation professionals. If that wasn't enough, we have a quiz for you, an aviation prize quiz. I have a prize of a lovely Bluetooth speaker here, which I can thoroughly recommend, owning one myself. That would be 10 questions using an interesting format I've discovered recently on family quizzes, called Kahoot. So you will need, I'll warn you, you need a separate smartphone or separate computer device to be able to access that, because it's quite interactive. I hope you like that. That's 10 questions with a prize. And then we have a Q&A session. If anybody has any questions from any of these presentations, or from any other aspect of the of what we're talking about, please use the tab at the bottom of your screen, and just you can put those, and I'll put those questions to the team at the end. So that's what we're going to be doing today. I'll hand you on now to Keith on the first presentation, which is aviation recovery update and regulatory guidance. Over to you, Keith.
Well, thank you very much, Robert. Hello, everybody. Good morning, good afternoon, and good evening, wherever you're based around the world. Last week, we celebrated Civil Aviation Day. Very, very interesting, because we know we've all been on the receiving end of this very difficult period with COVID, but hopefully we are seeing the light at the end of the tunnel. Having said that, let's have a little bit more look about the aviation side of COVID. What has been very, very interesting is that in Europe, together EASA, which is the European Union Aviation Safety Agency, together with the European Centre of Disease Prevention and Control, I've identified that actually traveling in an aircraft itself is not high risk in terms of spreading COVID. The air conditioning side in aircraft are high tech. And so actually, providing we separate in the normal separation, etc., and in that particular enclosed environment is not high risk. The issues occur arriving at the airport, prior to arriving at the airport, and then departing from the airport upon arrival and out into the in the public domain. So that's where the risk factor there is, rather than actually flying. But of course, the effect is that because of all the travel bans, then we've had a very, very difficult period. So we can rest assured that if we're sensible and we're sitting in an aircraft and we've taken off and until we arrive, we're actually relatively safe. And that's a really good thing to know. However, when we're looking at what has happened over the past few months, and I've just pulled out a thing from Eurocontrol. This is actually a slide that was issued by Eurocontrol last week, and it takes a little while, to gather information. So this was between the 9th of December and the 11th of December, that when we look at international travel, and I'm not talking about domestic travel here, we're talking international travel, traveling in those corridors, those travel corridors that have been opened up to various airlines and routes, then on average, then out of Europe, as an example, to whether we go to the North Atlantic, Mid-Atlantic, the Central American area, the South Atlantic, South America area, or into Africa, North and South Africa, Middle East and Asia, and other areas of the European area, going north into Russia, etc. Then overall, we are currently on 2019 flight data, minus 57% on average. So that's basically counting up all these percentages, dividing by the number of percentages to get that. And so really, it's been a difficult time and continues to be a difficult time. But what is important is that we are going to come out of it. Now, we know that that COVID, there's reports now of different strains of COVID that may have an effect. But certainly, as we look forward, we are planning at this moment of time for the next 6 months. So into the first half of 2021, we need to be looking at what we're going to do in terms of the recovery. And what has happened is that during this 2020 difficult period, and I'll take one example. Now, who's been affected? The traveling public have been affected. But when we look at the traveling public, we're looking at the airports and we are looking at the airlines. And of course, the services behind that give us the airports and the airline facilities, the air facilities, etc., including air traffic, etc. But I'm going to take one example. In Europe, KLM, that's the Dutch airline, part of the Air France KLM consortium or network. Then KLM themselves, as an airline, have had to discharge, get rid of, and say farewell to over 5,000 personnel. Now, very interestingly, just last week, it was the final 2,000 of them actually departed from KLM. Now, if you start to think about the experience that has been lost to our industry on the airline itself, now the knock-on effect, if the airline do not have passengers, which we know, then of course the airport do not have visitors that are departing and arriving. So the knock-on effect of the services of the airport, not just the airfield, but the airport, the terminal facilities, etc., is a big knock-on effect. And in KLM, those 5,000 personnel amounted to 60,000 years of combined experience. 60,000 years lost to the industry, potentially forever. And I've got a little thing of this, where little shots where staff, the airline staff themselves were departing, and au revoir. And potentially, as I said, au revoir forever. But we need to be positive. We need to look forward. One of the aspects which I'm going to talk about later is losing that experience. Airlines have lost lots and lots of persons, because KLM and every other airline in the world is the same. But then we look at the airports, and then we look at the airports. There's landside and airside. When we look at our particular area, airside, and then we start to look at that, the fact is that we've had aircraft being parked up on our facilities, on the runway and taxiways in some airports. Aircraft are parked up heavily with fuel. They can't park them up with empty fuel tanks, so the fuel tanks are filled, and they'll sit there. And that mass is then pressing down onto the pavement and just sitting there. And therefore, we've had to look at the servicing associated with the airfield during COVID. But of course, access has been available. So there are some airports that have been able to retain staff at work rather than furlough them. And those staff that have been able to be retained at work have been able to get access out onto the airfield to do pretty much important maintenance work, which they were unable to do prior to COVID because of traffic density. So there's been a whole change of thinking, but also the commercial side comes into the airport. On the commercial side, naturally, no income. How do you pay your staff? So now staffing levels have been looked at. And a lot of people then who are very senior in positions, in terms of what I mean of longevity of service, then they've taken early retirement. And in taking early retirement, we lose a lot of experience. So the younger personnel who are left, then basically have to take up that mantle, that umbrella of those experienced persons. So I'm going to talk a little bit about how we've had to relook at training and really look inwardly at ourselves. But here is this little bye-bye, and this is what has happened. But let's be positive, because ICAO have looked. If you go onto the ICAO website and you type in the COVID-19 response and recovery platform, then there is a whole range of documentation which can assist airports and airport authorities, the civil aviation authorities, to actually bring us back into what we call normal operations. And I think we now all know we're going to be calling it the new normal operations. And so one of the elements that which I've actually kind of linked onto at the moment is how we're going to impart that advice. And certainly here in the UK, the ICAO and the UK Civil Aviation Authority have actually providing now some virtual training courses associated with returning back to normal operations. And of course, the main and the key issue is that when we return and slowly return back to normal operations, then it has to be done safely. So we are looking at the airfield facilities. We are looking at the safety programs associated with operating, and really it's something which it's close to all our hearts, and because we fly, even though we work with airports, our airlines, we all fly, we're on holiday, so do our families, and we want to be able to provide a service, again, a safe service, because it doesn't matter whether it's one aircraft using a taxiway or a runway, or 100 aircraft using a taxiway and a runway. Those services have to be compliant, 100% compliant. So that's both on the ground and in the air with air traffic services. So what I'm going to do now, I think that really kind of brings us up to date, really, of where we stand today. We're currently at, say, minus 57% for international flights globally, but we are looking, we do see the light at the end of the tunnel. So one of the elements that we spoke about before in the webinar series was the precision approach path indicator. And thankfully, we've got Tony, who has developed the PAPI, to join us again. Thank you, Tony. And over to Tony now. And so I'm going to go on to the next slide, and Tony will remember the past, so he'll give us a little bit of historical data and plus latest news. So I'm going to stop sharing now, and I'm going to invite Tony to come online. Tony.
Thank you, Keith. Well, it's good to say hello again to many people who, because of Zoom, I've come to be acquainted with over the last 9 months. Who would have thought back in 1955, when I started my career in aviation research, in this year I would be Zooming all over the place. As said at the top of this afternoon, it's a word we didn't even know at the beginning of the year, most of us. When I think back, 1955, there were no computers. Well, that's not quite true. There were computers about 20 miles down the road from where I was at the Royal Aircraft Establishment, in a place called Bletchley Park. And contrary to what you may have understood, the computers we know it today was actually invented there in about 1942, but it was top secret. So it existed, but it wasn't available to most people for a long time. And of course, very few of us even had a television set in those days, and many of us didn't have a telephone. And think the difference in communication today. Just a general thought as I start to think about what we might think about for a few minutes. So I look back briefly on my career, which was so exciting and fulfilling. I in my school days, I thought I liked the idea. I think I had a physics master who was very encouraging, and he encouraged me to look at. Hello, that's an interesting picture. Encouraged me to think, well, I could have a career inventing things and playing with aeroplanes. Well, in my teens, I thought there was nothing better than that, and the Royal Aircraft Establishment gave me the opportunity to do just that. And so I found myself over the years looking for a lot of my time at aids for pilots taking off and landing safely in all sorts of conditions, all sorts of situations, on airfields, airports, which are primary consideration today, but also onto ships, heliports, oil rigs, anywhere where aviation, as it were, could take place. And that led me to look at all sorts of aids to the pilots. Today we're looking largely at lighting, but it may be perhaps incredible to realize that back in the late 60s, I, with colleagues, was looking at head-up displays as a means of helping pilots make approaches to land in reduced visibility conditions. And I had colleagues who were looking at direct voice inputs to communication. That took about 25 years for that technology to emerge in the general public. Things do take time. But I remember discrete electronic components, the first transistors. We had diodes. That was one of the first things. We found that if you put the wrong polarity on the diode, it glowed in the dark. We were looking at an LED. We didn't realize at the time, but there in around 1960, I was playing with LEDs. Didn't realize it at the time. But moving on to 1970s, that's when I really started getting involved with ICAO and visual aids on an international scale through the visual aids panel. And the panel at that time was looking at upgrading the approach, runway and taxiway lighting for two reasons. One was that there was an increasingly an understanding that large aircraft like 747 and aircraft also with perhaps some difficult geometries like the Concorde were coming into operation. And on top of that, fog flying had done a lot of research, and the precision approaches, the time was coming to move from category 1, which had been for a long time, 200-foot decision, to move down towards a zero-zero landing. And so it was necessary to do research into redesign the lighting to make sure that was appropriate. And as I say, right across the board, from the approach lighting, the runway lighting, and the taxiway lighting. And that revolved me actually in quite a lot of actual fog flying. We had an ability at the RAE to fly in whatever weather we liked, never mind what the regulations said. We had a sort of personal dispensation. We could go anywhere and do anything. In fact, the safety was down to us, to what limits we operated to and to where. That didn't make us foolhardy, because usually we were in the airplane doing the tests. So, and then thinking about it, I'm probably the only person on the Zoom today who's made well over 100 landings in practice 0-0 visibility. I've seen it from the front and seen what it's really like, and that's important when you're doing visual aids development. Actually, while we're doing that fog flying, I remember one occasion we took off to go to another airfield to talk to folk about actually working all-weather operations. When we went to set off, it was very foggy. We took off. That was no problem. We approached towards the airfield we were going, called up air traffic and said, we'll be with you in 10 minutes. And they said, we're closed for operations. We're not operating. We said, yes, okay, but we're different. We can do it. We will come. So they said, well, okay, the runway's clear. There's nobody around. So we approached, landed in a very thick fog. And as we decelerated to a taxi speed, looking for a taxi exit, air traffic said to the pilots, where are you? And the reply was, we're on your runway. We were the only people that knew what was going on and knew where we were. But during that time, apart from redesigning the approach and runway lighting, took a particular interest in the taxiway lighting, because the ability to move in low visibilities all over the airports was becoming quite critical to keep movement rates up and keep it safe, when in fact the control tower a lot of the time couldn't see most of the airport. And so I started a program of looking at what would be required in terms of taxiway lighting performance. And we were starting basically with the assumption we had to have lit taxiway centerline lights, which would be green, as they already were in places like Heathrow. But the thing about Heathrow, they already had centerline taxiway lights, but they were omnidirectional and low intensity and weren't going to be fit for the job. So I got access to a number of major airports in the UK to actually look at what was actually going on in the lighting as it then was. What would you have to improve, both the runway lighting and the taxiway lighting? On the runways, I was surprised when I actually took a photo cell and started measuring the lights to find how poor the output of the lights was compared with what it said in the then existing Annex 14 regulations. I saw airports that had recently been certificated by a flight check by the regulatory authority saying they were serviceable, whose maximum light output was only 5% of the book value. I pointed this out to the Civil Aviation Authority, and eventually the CAA did fund some research, but it took a good 20 years to get to that point. But we persevered, and it's a good thing we did, because we wouldn't be here today if it hadn't been for that funding from the CAA, of which I was the technical monitor that produced what TMS produced for monitoring approach and runway lighting, and then taxiway lighting, and all the other good things that we've been talking about in the webinars. I remember during that time doing some measurements of taxiway lighting, as I said, on various airports, and we found the light outputs again were very, very poor compared with the book values. Two main reasons. One was the inside of the fittings was often full of water, very poor maintenance of the lights themselves, but also the lamps didn't seem to be terribly bright, and so we asked to go to the B centres and measure the current at the B centre to see if there was a fault. The staff took us there, said no, there isn't a fault, so we have you got 6.6 amps going out of this building? Oh no, it's 5.7. Why is it 5.7? Well, if it's 6.6, we can't keep up with the number of light bulbs that fail. Bearing in mind, we're talking about tungsten halogen lamps in those days. So they, at the level of the foreman in charge of the servicing night by night, had turned the primary current down to a level to which they could change light bulbs and keep up with the situation night by night. And so we actually got to the point where we could say to an airport, how many people have you got on roster, on staff? How many lamps are you maintaining? We could say to them, okay, so you have actually got 5.8 amps set on your B cent, haven't you? How do you know that? Well, we learned by experiment, and that was going on. All a reflection of the fact of bad maintenance and inadequate staff training and so on, resulting in equipment that was bordering on the dangerous at times. So out of that came much improved lighting performance, but still the requirement to monitor it. And I'll come back to that a little in a few minutes. But just to say that I remember not only were there issues about flight checks and the value of them, what was actually happening in terms of the current that was going off the lights, but I remember going to the United States and actually going to a military establishment, actually an aircraft carrier, with Charlie Douglas, who at that time was the chairman of the visual aids panel, a world-renowned expert on photometry. And we went to this aircraft carrier to look at the lighting because the pilots had complained. And we went onto the flight deck, and Charlie said, will you put the lights on? And so the lights were put on, they said, from the control position. We looked, we couldn't see really any light. So Charlie got down on his knees, put his hands over the small aperture where the light was coming out, peered into the little darkness. He said, oh yes, they're on. But you could only, they were so badly maintained. And that was everywhere. It was just like that. So as I say, thankfully the CAA put some funding in to develop the in-service monitoring that we now have. But in parallel with that, and this is where I come on to the PAPI story again, in the early mid-70s, there was a feeling abroad that all this business of I'm a big city airport, I have to go right out to the suburbs to get onto an aeroplane to fly perhaps 300 miles to another city and then have another hour getting back into the middle of the city. Why don't we have city centre to city centre, perhaps small airports? And perhaps it'll involve a steep approach because of noise abatement and obstacles. So research projects were set up, and in the UK we had one to look at the concept of a runway only about 4,000 feet long and 100 feet wide, with approaches made at least 6 degrees by an aircraft capable of approaching at about 100 knots and carrying about 90 people. But the approach would be with an autopilot down to 50 feet, from which point the pilot was to take the airplane and flare the airplane and land it precisely. That was the concept. Well, at the RA in Bedford, we set out to do some flight trials, but of course there was no non-visual guidance and no autopilot that could fly 6 degrees or anything like it. And so I was tasked with, well, can you make a visual aid where the pilots can actually fly as precisely as they would if the pilot was coupled to an ILS at 6 degrees or even greater angles? And so that's where my invention came up of the PAPI. In a matter of 2 or 3 weeks, we showed the principle worked, and it was really, the PAPI was originally developed, therefore, just as an experimental tool, if you like. But the pilots liked it so much that our test pilots and people that came and flew, pilots from the CAA and so, they all said, "Oh, this is much superior to the Varsi, which was then the worldwide standard. This needs to go as a replacement." And from that point to actually in 1983, getting PAPI into service through ICAO was about a 10-year program with a lot of development flying and a lot of experiments. And I would point out, I think it's important in some of the solutions we're going to provide for PAPI sighting, that we actually show that you could fly the PAPI as accurately as you can fly the ILS. You don't have to really take account of big deviations from the nominal 3-degree glide path. If that's what PAPI set to, you'll get 3 degrees with very small errors around it, just as you will with an autopilot following the ILS. So whilst we were doing this development work, we came under the umbrella of ICAO. ICAO set up a working group to look at PAPI, and over 3 or 4 years, several nations evaluated in various ways at airports and their research facilities. And so in the early 80s, we were able in the visual aids panel to look at the data and make that decision. It was interesting during those development trials in the UK. We went to about 15 different runways, if you like, different airports over about a 3-year period with temporary installations. But we did, perhaps the crowning piece was going to Heathrow and Gatwick, the 2 major airports, putting PAPI on the left-hand side of the runway, leaving the Varsi on the right-hand side. So if you like, the licensing issues were maintained. But the fact that the PAPI was there and what it was to do was known to all pilots. And they were asked to fill in a questionnaire and then submit that to CAA for evaluation. And during that period, I remember there was one occasion when a pilot who was flying long haul, who'd been to the other side of the world and back over many days, the NOTAM had been issued and the PAPI had been switched on while he was away from Gatwick, which was his home base. When he got back to the, having landed, he went back to the company offices and said, "Oh, I just noticed on the way in, there's a set of lights appeared on the left-hand side of the runway. Some are red and some are white. And if you maneuver the airplane so that you've got 2 red and 2 white, you're on a 3-degree glide path." Well, we were delighted to hear that because it showed that PAPI signals are pretty self-explanatory. You don't have to go on a long training course to be able to use PAPI. And that was a sort of feather in our cap. We also had a couple of occasions during those times when air traffic said, "Will you come and look at your PAPI? It's gone out of alignment." So we went, and on two occasions, different occasions, we found that the PAPI was perfectly in alignment. The ILS had gone out of alignment. And so the PAPI was a very good means, if you like, of checking the ILS alignment. Contrary to what many people tend to think perhaps of PAPI as being a rather inferior guidance aid to ILS. PAPI properly flown gives you as good an approach as does a coupled approach on ILS. The other thing we noted was that several pilots commented that below 200 feet, they'd been nicely stabilized on the approach, and below 200 feet, they'd experienced wind shear, the situation where the wind direction changes in turbulent conditions very markedly in the latter stages of the approach. And so instead of perhaps approaching into a headwind, suddenly below 200 feet, the aircraft has got a crosswind of many tens of degrees, and that can change the approach profile of the aircraft very suddenly. And three pilots in their comments reported the first thing that told me I was into a wind shear was when the PAPI started winking at me and changing color. So many of the features, these were recorded and told to ICAO, this is a very safe aid. We need to adopt it. So it was adopted in 1983, and that was good. But of course, we're nearly 40 years on, and what came out of our webinars very much was that what's in Annex 14, the standards and the recommended practices, and what's in the Aerodrome Design Manual, Part 4, about installation and how you actually do it in detail, they've got rather long in the tooth, and we're in a different scenario. Aircraft, the types of aircraft, the mix of aircraft have changed a lot, changing again now with the large retirement of the very large aircraft, the 747s. They're going out of fashion and indeed out of service for passenger aircraft. British Airways have got rid of all of theirs. We're never going to see the like of that again. That has an impact on PAPI alignment issues, which have been discussed at considerable length. Also, we are aware that in the medium term, ILS may well die out of, and the guidance will rely on GPS guidance. Well, that's interesting because at the present time in the SARPs, it talks about harmonizing the PAPI with the flight path that is followed by the ILS on the aeroplane, the ILS aerial. Well, there won't be an ILS aerial. So what is going to be the datum point on the aeroplanes for the future? I think it'd be a great mistake to say, well, we'll put a pseudo ILS in our calculation. Probably the best thing would be to say, well, the thing that really matters is threshold clearance of the wheels, and use that as the datum and work from the wheel clearance at threshold upwards into where we cite where the an instrument approach will nominally reach the runway and where the PAPI guidance will. So we were invited through the good offices of our friends in the CAA to put a paper into the Civil Aviation, to ICAO, the Visual Age Working Party, which was meeting in Montreal in the beginning of December. And so Robert and I, Robert introduced me and I produced a paper explaining what the problems were with the PAPI siting, saying there is quite a widespread feeling dissatisfaction with what's there and the difficulties of understanding it, implementing it, and going along with that, the concern of now I've got this PAPI, I'm at this airport, I'm responsible for it. How do I know it's working properly? And this is where we come back into another aspect of TMS, of course, with the possibility now of actually, with the equipment that they can supply, you can actually very accurately measure the output in all the key parameters, color, brilliancy, setting, and important setting angles. You can have a tool where, if you like, you can be absolutely sure both when you install the equipment and the manufacturer installs it for you. You can check before it goes live that it's according to the SARPs. And also from then on, you can do periodic maintenance checks and make sure the unit is still as it should be, and take remedial action if necessary. So that's where, if you like, the stories, as far as I'm concerned, coming out of the webinars, is that at that meeting on the 2nd of December, the working group listened politely to my presentation, then had some discussion and agreed that they needed to have this as an agenda item and to work on this revision of Annex 14 and the ADM Part 4 to more better reflect what the needs are after 40 years. It's hardly surprising. After 40 years, most things have been refreshed and brought up to date. I don't think you're driving the same car as you drove 40 years ago. You probably haven't got the same kitchen facilities that you had in your house 40 years ago, if you can remember that far back. We change with time, and PAPI needs a reviviation of its life for the future. And I think there's another meeting of the Visual Aids Working Group in May, and what we have on our agenda is now to produce the documentation. I've done some work on it. We can simplify the calculations considerably in where the PAPI goes in relation to ILS, or indeed where the PAPI goes when there is no ILS. Some of the calculations, you don't even have to do the math. We can have very simple lookup tables. For example, how far upwind of the ILS do you need to put a PAPI for harmonization with the range of aircraft types you're operating? It's a straight line graph. You can read off, if you know what your eye to aerial height is, and the range of those, take an average of that, feed that in, and read across, and that gives you a sighting. You don't have to do any maths at all. So it'll take you about 30 seconds to decide where you put your PAPI, and on credible data. So that's where we are. And I think that's probably a good place to stop at the moment. There may be 1 or 2 questions afterwards, but thank you for listening to me. I hope that's helpful. Those of you that had raised issues about PAPI, I hope you feel that it is your concerns are being taken forward, and hopefully there will be some positive action taken on them. So back to you, I think, Keith.
Right. Can you hear me? Hello.
Hello.
Hello, I think we're back. Thank you very much, Tony. Remembering the past and latest news, and thank you so much for the historical data, and I think also where we're going in the future with one element of AGL, which is the PAPI, which is, I always say, is our direct influence on flight safety. It's a very critical time of flight, which is the approach and landing. And here we presentation to share it again. So I'll stop share and open my share screen again. And here we have, oh, it's not moving on for some reason. That's interesting. So what I will do is stop share again and go out of the presentation and unopen it again, reload it. So just excuse me for a moment, then we will.
Just whilst Keith does that, I'll just remind you, if you can have a mobile phone or another computer, a tablet, or some other device handy for the quiz in a short while. Fabulous prizes available. See, You can't. Interesting. You can't see that. But that is in fact, I'm holding up an invisible Bluetooth speaker. Very nice speaker, high quality, very highly rated. So that will be sent. That will be sent to the winner of our prize quiz after Keith's next presentation. Yes, thank you, Tony, for that very interesting talk. It's very interesting to hit. It's very interesting to have the stories to put the developments in our industry in context, and you do that so capably because I mean you've developed the technology, you've written the standards, and so you absolutely understand the subject matter inside out. And
do you have the presentation back on?
Yes, we do. Yes, we do.
Okay.
It's on Tony's page, though. PAPI
Yes,
Master.
it is. It is on Tony's page because I had a couple of slides there for Tony, and maybe you like to just come in here, Tony, about the next steps. And this one, of course, is.
I think in my talk I've covered most of those, but this is a good a summary at the end of it.
Yes, of course.
And the key to much of it, you probably picked it up as I talked. The key to it is understanding that the PAPI, when you're flying PAPI, you're flying with an aid which is just as accurate and has just the same small perturbation errors in it as does the ILS. They're very, very similar actually, and quite a lot of the problems with the sighting, doing the calculations, has been the assumption that the ILS is perfect and has no variations in it, whereas the PAPI can vary anywhere within the on-slope sector. And the reality is that is just not true. And that can be shown from the data that we presented to ICAO in the early 80s. It's documented in probably the eighth meeting of the Visual Aids Panel, if I recall correctly, the graph showing the flight paths achieved with PAPI. And incidentally, some that were achieved with vases, and the difference is incredible in terms of the accuracy of flight path. So that's what's coming, and that's a good summary of what we've done and where we're intending to go.
Okay, Keith.
Right. And for some reason, my my screen is not jumping over, so I have to go back out.
For those of you that have been doing Keith's recent training course, you'd be pleased to hear that the training is not the quiz is more general in topic. It's not specific to the training course we actually have taken. Although I know many of you will be knowing those answers, but so yes, do try and take part in that. I think you'll enjoy it.
Did you see? Do you see this presentation now?
Not yet, Keith.
You don't see it yet?
No.
Okay. Well, let me.
There we go. We're guessing it's working. Apologies for this. It's the wonders of modern technology.
Yeah, one of the interesting things about it is when you go out of Zoom, and there's something we learn about Zoom. You go in, you go in and out of Zoom. You have to reset it. Interestingly, and anyway, so here is the presentation, which and this picture here is a nice one. The bottom picture there on the right hand side is actually the London City, this inner city airport, which Tony was talking about earlier, which actually drove the requirement to relook at the visual landing aid.
Yep,
so,
that's right.
Anyway, so sorry, Tony. Yes.
Yep, that's correct.
Yes, and anyway, so let's go back to what we were talking about a little earlier is associated with losing experienced staff. So there's going to be new people coming into the industry, and we've had to relook at ourselves. And so let's remember back to webinar 14 and then looking at training. And when we look at training, we have to remind ourselves that we have to be competent as airfield ground lighting. Now, airfield ground lighting is a mixture of control systems engineering, power, electrical power engineering, and distribution engineering. Of course, photometrics at the end of the tunnel, the light at the end of the tunnel. And so when we look at competency, we've had to really look at ourselves and say, are we going to be competent in the future? Were we competent in the past? So ICAO have issued what they guidance associated with to have training associated with competency-based training and an appropriate assessment to demonstrate the competency. And when we do that, we're demonstrating our performance standards by an assessment system. And so that is what here in TMS that we've Training Solutions, we now offer our CBTA as it's known. And clearly then when we're looking at this competency certificate or recognition, then ICAO also advise that upon completion of rig training, then you will receive a certificate to demonstrate your compliance. So it can be issued by an airport authority, an aviation authority, and it can be issued by a training academy, a recognized training academy, or even through the academic, if there are academic courses associated with airfield ground lighting through an accredited educational institute. And of course, within the ICAO and the ICAO Train Air Plus program, should there be any airfield ground lighting training courses, then it all comes under this being able to demonstrate that you are competent. And they're also very interesting. Then there is a life expectancy for a period of time on your certification, on your recognition. So maybe 3 years or 5 years, that's going to be an important factor in the future. So it's not just training and gaining knowledge, it's training and demonstrating that you can convert the knowledge into a skill and for a period of time, and then you have to be reassessed. That's the key issue. So how are we going to do that, and why are we doing that? It's because ICAO, and I referred to this in our webinars, ICAO undertook a safety oversight investigation globally, and out of that they came up with 8 critical areas. One critical area number 4, they identified that there was a lack of qualified technical personnel right across the industry, both on aircraft, air traffic, and airport. And therefore, then the statement that comes in on Annex 14, Annex 19, not Annex 14, Annex 19, then under CE4, critical element number 4, the state shall establish minimum qualification requirements for technical personnel performing the safety oversight functions and the appropriate initial and recurrent training to maintain an enhanced competency. So that's a key issue. Then note the word shall. It is mandatory on airport authorities and aviation authorities to make sure this happens. It's a legal requirement. And so what did we do? We first started and had a look here, look along the top here. We kind of looked at way back in time, over 20 years ago, into the late 1990s. Then we were looking at airfield ground lighting. And in that period of time, then, and I was involved with some other colleagues, that we looked at how we could demonstrate and have a recognized training format. And that's when the AGL 1, 2, 3 concept was derived. But that's been around for 20 odd years. And in that period of time, it's evolved itself into product-based training from suppliers. Suppliers do their own training, but they customize it to suit their own products. Then we moved in by investigation into computer-based training, looking at moving towards competency-based training. And then certainly in 2015, we certainly looked at proficiency-based. Proficiency, how do you demonstrate you are proficient? And that is where really, when we came to where we are today, then we needed to adopt some kind of competency-based training and assessment formula to do it. So hence, we looked at how other elements in aviation was doing it, and we leaned towards looking at the electronics personnel that look after the comms, the radars, etc. Now, the ATSEPs, as we know, the air traffic services electronics personnel, and they have a program. They had a program which is a stepped program in phases. So we've looked at those 4 phases and said that's ideal. The structure is ideal. So we do basic training, which is generic, and so we have some general training, and then you will see in a moment that we split that into 2 parts, and then we move on to the qualification training phase. And in the qualification training phase, you may be a designer, you might be an installation contractor, you could be a maintainer. So there's different job functions within our sector. So we need to have specific qualifications associated with our job functions. That's in phase 2. And then then remembering what ICAO identified is that recognition and certification is time limited. So we need to have a continuation training phase. So we can return back. So after 3 years or 5 years, then we can do some training, more training. And then also there's a further phase, really on the end, is then we have a job change. Maybe we go from being an electrician in the field to being the supervisor of a ship, from a supervisor to be a departmental engineer. So there's levels of electrician, technician, engineers. Then we need to have a development process. So that's also how we've merged. So looking back at our training phases, which are shown in yellow with the red boundary, phase 1, phase 2, phase 3, and phase 4, and that is what we've done. So this slide shows it on the left-hand side. Then selection. We're going to select some people. Now, the thing about selecting, we're electrical personnel. AGL is an electrical system, basically. So we need to have electrical trade training. But unfortunately, that electrical trade training is based on constant voltage. And therefore, we need to have an adaptation into constant current, because currently around the world, most airports, AGL, are fed from a constant current source. And so therefore, we've got a selection. We'd select people who have got an electrical qualification. Ideally, if they've got an aviation background, that would be perfect, but not mandatory. But then we have 2 levels of basic training. 2 levels. First, basic training 1 is based upon airside induction, how to drive, how to talk on the radio, how to work and operate safely in and around an airfield where there's an active manoeuvring area. The second part of basic training is that familiarization with airfield ground lighting and the conversion from constant voltage to constant current, for example. And then we move on to qualification training. Qualification training, as I've already mentioned, there are different functions, job functions. So we have different streams of those qualification training, which is by job function, as you'll see on this part of this flowchart. Then there is the assessment. Now we need to have a feedback system. So we either pass and move on, or we need to have further training in some areas. So we either return back through the basic training, or we go back to the qualification training if we fail to meet the required standard. The standard associated with an assessment process. And you'll see on this slide, adjacent to competency assessment is the assessment process. And that is split into 3 areas. And I'm going to show you another slide on this in a moment. But knowledge, skill, and attitude, which is skill is showing your proficiency with the knowledge that you've gained, and the attitude is the human factor side. And so that assessment process. And once then we are recognized, and then thereon we can get on with our daily tasks, our daily jobs. But then when technology changes, when on a time limited basis, then we need to have continuation training. And as I mentioned, their development training when we have a career change. So this is the flow chart that has been discussed and will be proposed by the IEC. We have been invited to submit this through the International Electrotechnical Commission in the review of the IEC standard 61820, and this is what we'll be submitting. On the assessment process, then assessment is based upon 3 elements: knowledge, gaining knowledge, applying the knowledge in a skill, how proficient you are, and when you put that together, that's all how an individual works. That is the human attitude process. So here, look, I show here, look, there's 3 parts to that assessment: 1, 2, and 3. Knowledge, skill, and attitude. And within that, the knowledge will be a multi-choice questionnaire with a minimum percentage pass mark for everybody. However, if you're an electrician, we would expect you to a minimum pass mark that's 70%. If you are a supervisor, then the expectation is that you get 80% of that exam. And if you're an engineer, departmental leader, etc., we'd expect you to have a wider knowledge. So we'd expect you to get 90%, although the baseline is a 70% pass mark. On the skills assessment, then that's a practical assessment, and a trainer then would submit, etc. And on the attitude, the human factor side would then be the annual assessments associated with through the human resources department. So here is a structure which will take us into 2021 under CBTA training for AGL engineering personnel. Very, very important. So let's have a look at what we're doing in TMS. Well, let's have a quick look for 2021. Look at us, call us. There is our website, www.tmstrainingsolutions.com. Go onto the website and you can contact us. And we are actually declaring already that in February of next year, February 2021, we will do 12 online training modules as part of the CBTA program. It'll be online training. There will be 12 modules over 3 weeks, every Tuesday, commencing the first week of February. And then they will be recorded. So if you cannot actually attend the Tuesday, you have 5 days to return to the recorded presentation. And then on the following Monday, we will have a tutorial and a Q&A session, a question session associated with the previous 4 modules. And we'll do that each week. And then at the end, there will be an optional exam for certification and recognition purposes. So that is what we are proposing in the early part of February 2021, in February. And the reason why we're doing it this way is we do not think we will yet emerge fully out of COVID by then. So we online training first week in February 2021. Join us, register. So now we're going to move on to what Robert said earlier about the Christmas quiz and a bit of a Q&A session. So the Christmas quiz, and I seem to remember it was something to do with Kahoo. Is that correct, Robert?
It is certainly is.
So
Kahoot.
I'm going to stop share now and hand over to you.
You can stop sharing. You will be able to join me with this little. If you can get your device, get your device out. That would be great. Your smartphone or your PC, and we will commence the. I will now share the screen, and we will try for the first time ever our Kahoot training. So. Just let me do this. So here is my. So here we have this is the training. This is the. So we're going to now see a login code. You'll be asked to put that sign into Kahoot.it. So if you have Google, if you can get into Google or a similar search engine, and put Kahoot.it into your computer. We need you to put in a sign into Kahoot is now loading. So sign into Kahoot.it, and then it will ask you for a PIN number, which it is just about to reveal, and that will enable you to play this quiz. A short quiz, 10 questions. It's quite good fun. After each question, it will give you a league table to show how well you're doing, and the faster you answer a question, the better the score you get. So please enter now 3511-5998.
311-5998. Yes.
Yes. So you go into Kahoot.it. See, we've got 2 people entered there. I'll give you another minute to come in. We've got 4 competitors there. Wonderful prizes. This is good fun, trust me, and there's no shame, no embarrassment. This is just the questions are not generally that difficult. Oh, we have the AGL guy. Keith, you've got competition from the AGL guy. So go to Google Kahoot.it and then put in the PIN number 311-5998. If you don't want to do it, you can just watch the short quiz and take part in it. Just take part in it yourselves. So we've now got 9 entrants. Don't be shy. Really isn't embarrassing or anything like that. No general knowledge about aviation. I'll give you another 10 seconds, and then we'll just go with the people that have joined in, and we'll see. But you've got to be in it to win it. So right. Okay. Well, let's just start. We'll go with. This is the first time live. John's joined us. So any more? 5, 4, 3, 2, 1. You can see it. You can try it yourself, even if you're not online. But it's more fun if you are using the app. Now, when I press start, it will count down to the first question, and you've got 20 seconds to answer it. The faster you answer, you answer correctly, the more points you will get. So if you're still trying to get in, please carry on trying. The number is 31, and if you need to write down the PIN number if you need, because I will be It's 3115998. So cahoots.it. I'm going to start the quiz now. 5, 4, 3, 2, 1. Right, here you go. Okay, first question coming up. So which airline ran the first transatlantic jetliner service? So on your keypad, press the red button if you think it's American Airlines, the blue button if you think it's Delta Airlines, the yellow button if you think it's British Overseas Airways Corporation, and the green button if you think it's Pan Am. 1 second to go. Right. Okay. The correct answer was the British Overseas Airways Corporation, the forerunner of British Airways. And 3 people got it correct. So that means the leader with the fastest answer at the moment was Bart. So well done, Bart. I think it's, I guess, Bristol Airport there, coming in second, and they are in third place at the moment. Plenty of room, plenty more questions. Another 9 questions. So now with question 2. Where is the HQ of ICAO answer? Red Geneva, blue Washington, green Brussels, green yellow Brussels, green Montreal. Fast as you can. 2 seconds to go. Right. Okay. Let's see. 6 correct answers there. The correct answer was Montreal. Tony, why was it Montreal?
Why was it Montreal? It was compromised. There were those who wanted to have it in Paris or Geneva or a French-speaking country like that in Europe. The Americans wanted to have a country that sort of spoke English, and the Canadians offered both. They speak English and French. They're bilingual, so it finished up in Montreal.
Right, thank you, Tony. Right, so after that question, Bart still in the lead, narrow in the lead from Noah, followed by John, Steve, and Bristol. So that's the leaderboard at the moment. Next question, question 3 of 10. What do the standards LED stand for? As quick as you can, no pressure. Right, 9 answers, all correct. On, let's see the leaderboard then. Yes, so Bart, you're keeping your lead there over Noah. John and Bristol and Steve following up on your heels. So no pressure, you've got to get this one right. Next question. If an aircraft has a speed of 200 knots, approximately, what's its speed in meters per second? 200 knots in meters per second. Right. Yeah, 5 people got that one correct. 200 knots is 100 meters per second. As Tony explained to me, you simply halve the knots to get meters per second. So who got that right? Oh, Bart is still putting a bit of distance between him and the number 2 on the leaderboard. So on to question 5. What in aviation are an Immelman and a barrel? Is it a machine gun? Is it a manufacture of AGL? Is it a type of acrobatic roll maneuver? Or is it a World War II bomber? What are an Immelman and a barrel? 8 of you got that correct. It is in fact a type of aircraft aerobatic roll maneuver. And Bart still maintaining his lead. On to question 6. What are the 4 C's of AGL? Clarification, colour, climate, coverage, candela, configuration. There are your options. Right. Well, we've got 9 answers, all correct. So someone's been listening to you, Keith. So that's good news. Your training has not been wasted. So that means that Bart is still in the lead. On to question 7 of 10. What is the standard 2-class seating capacity of the Boeing 747-400 jumbo jet? A tricky question, this. Is it a chance for someone to catch Bart up? Right, well, let's put the cat among the pigeons. Only one right answer. 568 is the correct answer. And, we've seen Mary. Mary, where did Mary come from? Well, you boys, you're being you're at risk now. There's a lady coming up the leaderboard. So in our male-dominated domain, it's very interesting to see Mary on the scoreboard. So Bart, you still have a lead of 500 points. On to the next question. Which European city's airport is named after Wolfgang Amadeus Mozart? No surprise, it's in Austria, but which airport is named after Wolfgang Amadeus Mozart? 1 second. And 6 of you got that. Every answer got attempted, but 6 of you got it right. So let's see where that puts the leaderboard. John. All right, John has now taken a narrow lead over, so things are definitely getting close there with just a couple of questions to go. On to now question 9 of 10. In the 2004 film The Terminal, starring Tom Hanks, it's about a man who becomes stuck at which international airport? A bit of a trivia question there to challenge you. Was it Los Angeles, O'Hare, San Francisco, or JFK? Right, well, 6 of you have seen the film. The answer is indeed JFK Airport. With one question left, John stays in the lead with Bart, followed by Bart, followed by Steve, followed by Bristol, followed by Newar. And here we go now with the last question. After the United States, which country in the world has most airports? Is it red, Russia, blue, Brazil, yellow, Mexico, or green, Canada? Which country has the most airports after the United States of America? 3 seconds to go. And again, showing what a knowledgeable team we have on TMS Tuesdays. Majority of you got that right. It is indeed Brazil. 5 of you got that correct. So the final scoreboard is, in 3rd place, we have Steve. Well done, Steve. In 2nd place, Bart. And in 1st place, with 7,000 points, 8 out of 10 correct, John. Well done. So that's absolutely brilliant. So that's I better stop all that noise. That's extremely well done, John. That's so the prize of this beautiful Bluetooth speaker will be sent to John. I'm not sure which John that is yet, but I'm sure if you could make yourself known through the just in case there's no other way of checking, if you could make yourself known through the Q&A session and give us an address to send this to, congratulations. I'm wondering if it could be John Laheath there, who was a guest presenter on one of our webinars. But anyway, well done, John. Whoever you are, wherever you are, you certainly have. If it is John, you're certainly up very late, so added marks for that. So thank you for your contribution and participation. But I'm just looking through. If I look through the list of participants, I'm guessing it is in fact John Laheath. So yes, it is. So anyway, look, thank you very much, and thank you for your comments coming in. There is indeed one question there: how to calculate the mean time between failure of AGL. Well, what we're talking about is the average time between serviceability, a light becoming unserviceable, and I would recommend, as you would expect me to say, if you put one of these little yellow RFID tags onto the secondary lead, and each time when you purchase the light, and each time you do any maintenance on it, you record the results on your mum's photo bench, you will indeed have the statistics to show you the mean time between failure of all your different lights by individual light, by type, by make, and by manufacturer. And this will give you some very useful information, will identify any common causes of failure, and help you with managing your assets. Because as Keith has taught us very capably over the last summer, you can't manage what you don't measure. So I've learned my lesson. And so with that, I'd like to thank you all for your contributions to 2020. It's not been a great year, but I like to think that I think that Keith, together with Tony, have made fabulous contributions, and also Keith, I know you wanted to thank the. You have a list of names.
Yes, I do. Thank you, Robert. I think we also. I would like to say thank you very much, and also acknowledge not just all the participants of the webinars, but those who have contributed positively to the webinars, which includes, of course, starting with Tony himself, Tony Smith, who's the independent specialist, and we know, and and many of us recognize as the godfather in a lot of things that we do. I also like to say thank you to Paul Fraser-Bennison of Merlin Aerospace, ex-CAA and Visual Aids panel member, ICAO Visual Aids panel member. Thank you to John Laheath. He's now won our prize. Is it a fix? Come on, John.
No, I think John. I think all the credit for John is. I can't imagine. I'm just trying to calculate. He's probably back in Ireland, but if he's at home,
he's at home in Thailand. So
it must be about midnight there now. So thank you for
John. Thank you to John, Aerodrome Services, because he gave that excellent design webinar for us. Derek Calloway from Dewhurst Airfield Services. Derek provided us the information and helped us with the installation information, etc. To Eric Deleur and to Bart Plom of Pasiel Special Bow of the Netherlands, and of which provide a lot of information associated with installation of AGL and training facilities. So we work very closely with Pasiel in the provision of installation training. Steve Hutton, who is Australian, Steve, but he's currently in the Middle East as an independent consultant. And from an airport viewpoint, from Oman Airports, and as an airport authority, and the information and the approval to enable us to look at the practical elements of maintenance of AGL. And to Bart Marichal of Perfect Airport Solutions, he's based in Singapore, where he provided us quite a lot of information for the presentation portfolio associated with it. And of course, but not forgetting the team of TMS Photometrics, and in TMS with the MARMS family of photometric equipment, and on the asset management, the maintenance equipment side, and all the team within TMS that had worked so hard to really help us put not just the webinar series together, but of course service support and also for the future for online training and the practical trainings when we get on site again. So I would just like to say thank you so much to everybody in a difficult period of 2020. Let's look forward to 2021 with positive views. So thank you, stay safe, and a happy and a healthy 2021 to everyone and their families.
Thank you, Keith. And Tony, a couple of words.
Yeah, I'd just like to echo much of what Keith has been saying. You don't do this sort of thing on your own. It's a team effort. I was very grateful to have the opportunities during developing the PAPI work to talk to not only Keith, but folk like Robert Vitry in Brussels, well, in Belgium. He doesn't actually live in Brussels, but with a vast experience of installation, and one or two other folk like that who helped shape our thinking for the way we go forward. And I appreciate that. Of course, Paul Fraser-Bennison included in that. So it's been good, again, getting back, as it were, into the sort of international discussion and development of lighting in its various forms. So thank you for allowing me to be part of your Zooming time. Perhaps we'll be doing some more things in the new year. No doubt, some way we'll hopefully have some good things to say about what's going to happen with ICAO, with the PAPI siting in the not too distant future. So I want to wish you all the very best for the rest of the year, for the holiday season, wherever you are, and for the new year, that it'll be a good one, after what we say this year has not been, in many ways, a very good one. Let's hope that next year really will be good for everybody, whatever your particular specializations, interests, business interests, travel interests are. So thank you.
No, well, thank you very much. I would also, I'd just like to thank, very important, I'd like to thank everybody for who's actually joined us for these webinars and is on this webinar today. Thank you very much for your participation. I hope you enjoyed it. I just want to specifically call out Felicity and Rich for doing the majority of the backroom work on these webinars for us. But I'd like to thank everyone that's participated in these as participants, and of course congratulating finally John Laheath. If you could let me have your address, John, just send me an email. I will send this lovely speaker to you, and I look forward to seeing you, catching up in the new year. Best wishes to you all. Happy New Year. Bye bye.
Thank you.